Hello everyone, this is Mirza NAYEEM. In this video lecture, we are going to revise second unit part 2. Let's get started. In the previous video lecture, we are at coagulants. Right, we try to understand the coagulant with sedimentation. So now we'll try to understand dosage of coagulant. So how much dose has to be provided for this treatment, right? So before going to that, we are trying to understand the criteria to identify the dosage of coagulant. So first one is turbidity of water. So you have to know the turbidity of water, right? Next we have to know the color of water. So if the color is very dark, that means the impurity level is more. So next, pH value, the range of pH value, that is potential of hydrogen, we have to know. Temperature of water, kind of coagulant we are going to add it. So we know that there are n number of coagulants. The common one is alum, but we try to understand the kind of coagulant before going to find out the optimum dosage. Next, mixing. So we are using fluctuation time, right? Fluctuation chamber for mixing. So now we'll see a laboratory experiment, right, to identify or to determine this optimum dose, optimum coagulant dose. Let's see. So the test name is called jar test. And the apparatus which is used is called jar test apparatus, right? We'll try to understand this with a figure. Here we go. Yeah. So optimum dose of coagulants is determined by this jar test apparatus. Okay. This is called flocculation tank. So it consists of pedals. So these are pedals. Okay, and in jar test we are using beakers. So this is a beaker, size of 1 to 2 liters. Okay, let's say in this experiment we'll try to find out how many beakers are used. Let's say 1, 2, 3, 4, 5 and 6. Okay, there will be electrical motor connected to this shaft and it will try to rotate this pedal, right? So now to start this experiment, first we'll take water in beaker with equal quantity. Okay, there are 6 beakers. Okay, 6 beakers. We are taking 1 liter. Let's say 1 liter. 1 liter of water. Next, we are adding coagulant. We are adding some chemicals. Let's say alum. To jar 1 or to the beaker 1. Okay, so like that we are going to add different proportion of coagulant in each beaker. Let's say in first beaker I added 10 mg of alum. In second beaker I will add 20 mg, like that. 30 mg in third beaker, 40 milligram in fourth beaker, 50 and 60. Right, we have 6 beakers. Now the quantity of coagulant added is each jar is noted. Okay, note down this coagulant, the quantity of coagulant added in the beaker. Fine. Then with the help of this electrical motor, all the pedals are rotated at the same speed. So what is the speed, sir? So first 10 minutes we try to rotate or set this electrical motor to 30 to 40 RPM, rotations per minute. Okay, for after 10 minutes we'll try to reduce the speed about 20 to 30 RPM. Okay, now the dose of coagulant which given to the best flock. Okay, so obviously it will create some flock in the beaker. Let's say in this beaker there will be some flocks, some collaboration of solid substance. Okay, the dose of coagulant which gives the best flock is the optimum dose of coagulant. So whichever the beaker, whichever the jar or number, let's say third having more flocks than first, second and rest of the beakers, that is our optimum dose. Fine. This is how we are going to test or to determine the optimum dosage. So next we have clarifiers. Yeah, so you can see here in this operation the flocks that has been formed. So let's say here the flocks are formed, are allowed to settle down here. Then it is separated from the water. How it will be separated? So it will be separated from sludge outlet. Okay, it will be separated from sludge outlet. So this clarifiers consists of pedals. It will rotate and make the flock to settle in the bottom. Then it will, with the help of motor, this will be wiped off and the sludge will exit from outlet. So this is the concept of clarifier. So what are the advantages, sir? So there are few advantages and disadvantages. So requirement of chemicals is reduced by 20 to 30%. So if you know the optimum dose and if you know the amount of sludge or amount of flocks are generated, you can reduce the chemical, that is coagulant, in clarifiers. Better flock formation. For the formation of better flocks which can settle down in the bottom, we can achieve that. Less capacity of tank is required, therefore it is very cheap. So less capacity of tank is required. Okay, next, more flexible in operation. It is easy to operate. Very small less in head loss, so there will be no head loss here. Okay, no loss of water. It can be easily installed and it is in the existing plant. If you want to extend this clarifier, okay, if you want to extend this clarifier to a certain dimensions, you can do it. So that is a advantage. So disadvantages are dead space is corner. So there are some corners where we can't remove these flocks. That is a disadvantage. Low velocity near the shafts of pedal. There will be low velocity near the shafts. That means here near the shafts the velocity is low, and required careful maintenance, right, and supervision of clarifiers. So Next we'll see some mixing devices. It is actually not there in the syllabus. We'll try to understand filtration. Okay, so it is very important for exam point of view. It is asked couple of times in external paper also. So what is the theory? What is the theory behind this filtration?